All right, in this example, we're going to learn how to build a custom step. And then once we build it using Visual Studio, we're going to go ahead and configure that step within FlowWright and use it in the workflow process. So first thing we're going to do is we're going to open up Visual Studio. And in this case, I'm using Visual Studio 2019. And let's do a new project. And I'm going to make some selections from here. Once the screen loads, I want to create a .NET library. So class library. So we can say .NET Standard, or we can also do .NET Framework class library. So in this case, let's say we are doing a class library framework. And I'm going to select my project directory. And let's call this FlowWright sample step as the name of the project. And we're going to use .NET Framework 4.6.1 and say create. This should create a blank project for us in Visual Studio. And you can see I have a sample class created. The first thing we want to do is we want to add the .NET NuGet package to our project. So I'm going to go ahead and say manage NuGet packages. And I'm going to browse and search for FlowWright. And you will see the FlowWright API package. You're going to select that and you're going to select the latest one. In this case, I'm running 981. And I'm going to go ahead and say install. This is the easiest way to install DLLs, packages that are required for APIs. It will automatically bring down other extensions and other DLLs also that's defined within the NuGet. So as you can see, it's automatically added all the reference class libraries for us, and we are all set to go. First thing we're going to do is we're going to call this class, let's say CLS add two numbers. Let's say we're going to make this workflow step add two numbers together and return the result. And so now that we have public class, we're going to say we want to implement the DEI step interface. And you will see once you do this, you will get little quiggly marks saying that you need to implement this, or it might be the using statement. So I'm going to go ahead and add that. You can see FlowWright.cdev decision engine. And now if you click again, you will see it's asking to implement the interface. So the implementing the interface has one single method, which is execute. And what we're going to do is now we're going to implement the code inside this method. Before we implement this method, I'm also going to put some attributes. So I'm going to add one called step data. This defines information about the step. So the first one is step name. I can keep this blank because I can pick up the name of the step from the class. And I can give a step description. So I'm going to call this step, let's say, add two numbers. And I'm going to give my category as, let's say, FlowWright. Or actually, let me call it FW sample as the category. Next, we are going to add two inputs. Actually, we'll add three inputs. So we're going to say step input. And we're going to give input name, which will be, let's say, value 1. And input description, we are going to say enter value 1. And we're going to say required true. We're going to enter another one called step input value 2. and we're going to enter value 2. Now the third input we are going to enter would be to hold the result from our calculation. So let's put another step input called sum. Okay. And we're going to call it sum var global. Let's say we want to store the sum in a variable or global. So we're going to say variable slash global to hold the sum, and that will be required also. We can also return values based on the outcome of the step. So let's say, for example, we're going to return, we're going to use the attribute step return, and I'm going to say I can return true, and I can return false. Okay. So we have described our step now with the information it's required to auto-configure the step within FlowWright. So we have provided the metadata about the step description, what category it belongs to, and we have also defined the step inputs, and then we have also told what return values is going to this step is going to return. So first thing, you can see that this step returns CLS step return. So we are going to create a new object called CLS step return, and let's call it oReturn, new CLS step return, and the default value on the return is true. And the step state I'm going to return is complete. And for good programming practice, let's use a try catch block. Okay. And here I'm going to have an exception. So first thing we want to do in this step is get the values that are passed in to this value 1 and value 2. So let's get them as integers. So I'm going to say integer value 1. And I'm going to get those values using the engine context. So I'm going to use engine context, get figure property. There are two methods. One is called get figure property, and then there's also get processed property. Get figure property will just give you the value that is stored within the input of the step. The get processed property will give you the evaluated value. So for example, if you have a variable stored in this input, then it will give you the value of the variable. Okay? So just to make this simple, let's go ahead and use get figure property. And I'm going to use the one where I can define the type. I'm going to say I want to return it as int, and the name of my property is value 1. And we're going to do the same thing for value 2. And for third one, we want to get the variable or the global that's stored in the input. So let's call it string global. We call it sum. Typically, I name the variables also the same name as the inputs. That way it's easy to understand them. Global get figure property, and in this case by default it will return a string value. So I'm going to use sum var global. All right, now I can calculate the sum. So I'm going to say int sum equals value 1 plus value 2. And next thing I'm going to do is update this variable or global with this sum. So I'm going to say o engine context dot update variable or global, and I'm going to give the item name sum var global, and I'm going to give some .toString. And if we have any errors, we are going to log those errors using the engine context. So I'm going to say, engine context, write error. And in the write error, you can see I have a source. Typically, I give the name of the step. So in this case, I'm going to tell CLS add two numbers. And I can also pass in the exception. And I can also pass in a priority level. So I can say this is medium. And that's it. The rest of the parameters are optional. You don't have to pass them in. But if you like, you can pass them in also from the engine context. And that's all we have to do for logging. And now we just say return or return, and we're done with the step. Now we have a step that will take two inputs as numbers, add them together, and store the sum in the variable that's provided. Let's go ahead and compile this step. Let's say build. So our build is successful. You can see that it compiled everything. And what we're going to do is now take this compiled step DLL and put it into the FlowWright bin directory. So I'm going to go into the bin directory of this. So I compile this in debug mode. So let's go ahead and open, and I'm going to go to the bin folder and click on debug. And you will see that I have a DLL called FlowWright sample.dll. And I can grab, if you want, I can grab these three files or just the PDB file and the DLL. So in this case, I just grab all three. And we're going to go to the FlowWright bin directory, and we're going to copy them to the bin directory. So now we have added the three files. Since we have added files to the bin directory, .NET will recognize that we have made a change and it needs to load the app domain. This step will take a little bit of time to load because that is how .NET behaves. Whenever there are changes to the bin directory, it needs to reload the DLLs and the app domain. And as soon as this loads, we will continue with auto configuring the step. Until this loads, what we are going to do is we are going to create an image for the step icon. So typically what I do is I go to images, go to Google, and I look for free images. So let's call the add icon. And for now, we're going to, let's say, take one of these guys. Make sure you take these images that you have permission to use. Most images do not have permission to use. So I'm going to copy this image and I'm going to use this example. So I'm going to crop this image, and our icon size for step images are 40 by 40. So I'm going to crop this also to be, resize this to be 40 pixels by 37. And what you need to do is you need to save this as a PNG file within the images directory, and you want to use the same name as the step name. So in this case, we called, if you go back to Visual Studio, we call the step called CLS add two numbers. Okay, or I call it add two number. So I'm going to copy that, and I'm going to go to and save this image. And you're going to want to store it in initpub www.root cdev workflow images. So in the images directory, I'm going to give add two numbers and say save. and this will save this file as a PNG. Now we are going to go back to FlowWright. FlowWright is loaded now, and we're going to go to steps. So remember, we built in auto configuration into our step when we provided the step metadata. So if you go under utils and you can say auto detect, you can also tell which DLL you want to auto detect from. But in this case, I am just going to do auto detect, and this will go through all the DLLs and figure out all the steps that I need to auto detect. So here are a few other steps that I also have that I can auto detect, but let's look at the one from our step. So let's see the one that we have. So you can see the new CLS add to number step. So all you have to do is select it, and if you click on the expand button, you will see the inputs and the return values. That's for this step. So let's go ahead and click on let's select it and click configure. This will automatically configure the workflow step. And now if you go to our steps and look at the list of steps, we will have a new category here saying FlowWright sample, FW sample, and we have a step right here that is automatically configured. As you can see, you also have the icon, and if you double click, you can also see the metadata for this step. You can see the icon should be 40 by 40 pixels. Here's all the information. Here are all the inputs. Here are all the returns from this particular step. So let's go ahead and use this workflow step in a workflow. So we're going to go back to workflow definitions, and let's create a new workflow definition called add two numbers. I actually have this definition already, so let me call it def. And you will see on this toolbox here a category called FW sample now with one step. So we're going to drag that and drop it. And we are going to connect the dots. And if you click on this step, you will see that I need to provide a value 1. Here, if I try to save it, you will see that the validation fails. So I'm going to enter, let's say 28, okay, and 435, and we're going to use the variable dot sum to store the sum of these two values. And if I hit save, it's saved within the step. Now if I go to save the definition, you will see that it's going to complain that I haven't defined the variable sum, and if I want to define that. In this case, I do want to define it as a number, so I'm going to select number and say add. And now if I try to save it, the workflow will save without any problems. So let's go ahead and run an instance of this. So I'm going to create an instance right from here, and let's call it, I'm going to say generate a name for it, and I'm going to say create and execute. If your engine is running, it will automatically process that workflow, and it should be completed by now. In my case, I'm not running it, so I'm just going to manually say run the engine, and that ran the workflow. And if you look at the workflow now, you can see it's completed. If you click on the step, and if you look at the variables, you will see the sum has a value of 463 as the value, as the sum of the two values that were input. So this is a way to build a custom step, and also to use that custom step, configure it, and use it within a workflow process. The next piece I'm going to show you is also an important step in building custom steps and testing custom steps. We tested the custom step now using FlowWright process or a workflow instance, But now what we're going to do is we are going to test the workflow step. This is actually a new feature in 981 where we built a feature for you to test the custom step, debug the actual code within the workflow step using Visual Studio and FlowWright. So what we're going to do is we are going to go and select our step. Before 981, you would have to build a workflow process and test it there. But now we have a new way to test steps without using a process and also debugging through Visual Studio. So I'm going to go into FlowWright sample. In order to do this, make sure your workflow engine is not running. So make sure CDO workflow service is not running. So if it is running, turn it off. So we're going to say we want to test this step. So go under utilities and say test. This is going to give you a little UI based on the step. So you can see it's asking me to enter value. So let's enter some values. And here I'm going to say variable.sum. And what we want to do is if I run this, you will see that it will run and give me the result. But what I really want to do is I want to debug this step using Visual Studio. So I'm going to go into Visual Studio and I'm going to put a breakpoint on one of my lines on the step. And now I'm going to attach the debugger into the workflow FlowWright. So I'm going to say attach to process. And since FlowWright is running under IIS, I want to attach to the IIS process, which is the W3P. So if I search for just W3W, you will see I have that process. I'm going to attach to that process. Sometimes Visual Studio needs administrative privileges to do this. So make sure you start Visual Studio in admin mode. And now that we are attached to the debugger, you will see that this little symbol here is completely red. That means it's ready to debug. So now if I click the test button, you will see the code will jump right into the Visual Studio, and now I can debug this particular step. So here's the value 1. So value 1 has 45. Next is value 2, which has 245, and then the sum variable global has the value variable.sum. So here I add the two values and I update the variable and then I return and I'm done. So this is the easiest way to debug a workflow step. Hope you enjoyed this video. If you have any issues, you can always email us at support@flowwright.com, or you can leave us any issue in our Jira support desk, and we are happy to help you anytime. FlowWright workflow steps are very powerful. It's the easiest way to build a custom step to make the workflow do whatever you need. But also try not to put too much code into your workflow step and hide the process. You might want to break it up into multiple workflow steps, but also make sure those workflow steps are very reusable.